All right. So thank you all very much. Thanks for that awesome demo, Sandeep and Matsura. So I want to talk a little bit about Juniper Cloud Workload Protection. So my name is Krystle Portocarrero, and I am a product manager here at Juniper, covering cloud security. I think if you all have ever watched any of the other security field days, you might have seen me covering all manner of kind of other topics. But today specifically, we're going to talk a little bit about cloud workload protection and really what it means, right, to cover your apps. And so if you think about, all of the different things that are happening with a lot of organizations, it's really hard to find the right, balance of, things like time to market, innovation, uptime, availability. That's kind of why DevOps exists to begin with. And a lot of the changes that are happening in order to support, right, new application architectures, things like microservices, shifts to the cloud, and of course, continuous delivery cycles. Everything's really starting to move a lot faster. We spend a lot of time and money even on applications and the networks that surround them and interact with them, but security often lags behind. And so we're really good at the kind of better, faster, stronger piece, but what about harder? Right? We need security baked into these processes from the beginning all the way to the end to kind of harden the applications, because at the end of the day, all of the innovation that's happening, right, doesn't really do you any good if you can't secure it. And so we talk about digital transformation. You think about why businesses are looking to innovate, becoming more operationally efficient, adding, new and differentiated experiences to their end, kind of customers. Everybody's looking to transform their business for, a lot of the same reasons. And what is happening is teams are being pushed to deliver services quickly, right? Time to market and the business needs often become, kind of before security. And so a lot of I think organizations are struggling with this change, and it's not just a technology issue, right? That 48% of organizations that push vulnerable code right to production, knowing that there's vulnerabilities there, isn't just because it's not just a technology issue. That 48% isn't because we have lazy developers or bad security analysts that don't find things in times. Sometimes there's good reasons to push applications with vulnerabilities. You might have a legacy application that's going to be sunsetted. Are you going to spend a month of time developing a patch for something you're going to get rid of in 3 months? Probably not. There's third-party code. If you're waiting for your vendor to provide you a patch, that's just, you can't stop your business because you're waiting on something like that. And of course, I'm talking about patching. Upgrades and patching, right, and things like that are always they're time consuming. So time really becomes a huge factor in a lot of these things. It's often about trade-offs, as the organizations start to shift and things are moving faster, the security processes really have to align more closely with them and have to become faster as well. So it's important to remember that, when we talk about things like DevOps, right, automatable, repeatable are a lot of the kind of mantras there. But one of the inherent issues, especially when it comes to security, is that a single mistake can get amplified. So a misconfigured security policy, right? Instead of being on one firewall, it's pushed out to 20 firewalls. Or a SQL query that has no sanitization, right, in the code itself. Those things can take 5 seconds to create, but 5 days to remediate. And that's once you're kind of alerted that there's even an issue to begin with. And so you think about, I'm not generally a huge fan of these types of FUD slides, but it's something that I think most security-minded people are, kind of aware of, and the deck is stacked against the blue team. Malicious software has been turned into a business, which is pretty scary. You have malware as a service, you have DDoS as a service, spyware as a service. There are now entire businesses that have sprung up around exploiting, your business and your data, which is, a hard thing to deal with. And if you think about what security really is it necessarily about stopping kind of every threat every time? Or is it more about having the situational awareness to effectively make decisions that mitigate as much risk as possible? Because at the end of the day, the data and the applications that, services that are kind of hosted in the data center, hosted in a public cloud are the targets of a lot of these attacks. And it's increasingly important to get the security piece right in order to minimize that risk. And so talking about what Juniper Cloud Workload Protection is, we know that a data center, a private cloud, or even a public cloud, only really exists to provide services and host, applications. And those applications are generally kind of the core of what most businesses right? It's their business, right? It's how they make money. And so if you think about that application and what it is, almost everything we do nowadays on the network involves them. Web browsing, mobile gaming, chatting, online banking, and healthcare. And the applications are storing, processing, and exchanging data, and that allows us to connect with one another, right, here today, and really makes, I think, our digital lives possible. But if we go back to that amplification issue, you have errors in configuration or errors in the code that only get amplified as these monolithic applications that are, used to be running on a single bare metal server or a few VMs are just starting to kind of decompose into a sea of APIs and microservices and even serverless functions. And so all of these new architectures and processes have really helped enterprises increase the speed of developing applications and delivering kind of more value to their customers more quickly. Developers have become a really integral part, though, of this whole business. And so they're building things faster, and we have to provide more access to the end users as well. So the number of areas in which you have vulnerabilities potentially there are more, and then also the areas in which the application can be exploited, right, has increased exponentially as that attack surface becomes much larger. And so Juniper Cloud Workload Protection is really there to kind of integrate into a lot of the dynamic kind of development environment so you can scale as your infrastructure grows and keep security in line with those DevOps processes, especially when you're using kind of more cloud native tools and services. It also brings security closer, right, to the developer so they can resolve vulnerabilities quicker and earlier in the development cycle, because there's a huge cost to finding those vulnerabilities later, right, once they have been pushed to production versus during the development cycle. Just like it's easier to find bugs and fix them, right, during the QA process than it is to remediate them after the fact and provide patches, right? Nobody kind of likes that. So it's the same thing that's happening with security. And so, a lot of what we're trying to do here is just make it easier for organizations to find the right balance, right, for security and compliance, and then of course, innovation and time to, market. So this has really kind of two different use cases. We cover the first being the runtime protection. And this is really looking at how do we protect the applications at runtime, right, in the production network from exploitable vulnerabilities. So if an attacker tries to exploit something at that time, it's important that one, we stop them in their tracks, but then again, using the kind of power of the threat aware network, you take that information and you push it back to the network. And you make sure that at all these different kind of key points within the network, whether it's a physical, right, on-prem data center, in the cloud, or kind of anywhere in between, that information about who's trying to exploit your applications, right, is shared with everywhere else. And so the attacker can no longer try to exploit potentially another attack vector, and they can't move laterally within your network. The other side of it, though, is going really for the IAST, right, kind of use case. And so that's interactive, right, security testing. And this is during your development process, right? Just trying to find those vulnerabilities much quicker. You save a lot of time, you save a lot of money. It also saves, I think, a lot of times it reduces the friction point between your developers and the AppSec team. A lot of times the security team is seen as the department of no, and you say, oh, you got to fix all these vulnerabilities, but they're being pushed, from other places within the business, right, as a developer to keep moving forward. And so, having the same types of protection mechanisms, one will reduce some of that friction, but also in the times where you have to push code, knowing that there's vulnerabilities there, aren't you happy to know that the same thing that found that vulnerability during testing is also going to protect it in real time, right? It just makes a whole lot of sense there. And then to give a little bit of detail on how this works before I turn it over to Laurent here, is the kind of idea of deterministic security, and why this solution is fairly unique and kind of how it works is we're not just monitoring the application communications, but we're actually examining the application itself at runtime. We're kind of monitoring it from the inside out and watching how it executes, things like API invocations, or how a specific function is executing. And we're able to compare that to what should be happening versus what's actually happening. It also does all of this, kind of not using signatures, which means it's extremely fast and lightweight. every resource really matters when you're paying for them, especially in somebody else's cloud. And then there's no additional latency added either. It also reduces the number of false positives to pretty much none. Because if you think about an application, like if you ever gone out and downloaded a new app on your phone, and the first time you go to use it, you either can't access it at all, or you can't access it quickly. Are you likely to use it again? That's not the type of experience you want your users to have. So making sure you have things that are non-intrusive and aren't adding on a bunch of additional latency. Yes.
Krystle, may I have a question? The previous slide said that you don't do behavioral analysis as well. So, but now you say you compare execution of one function to how it should be. It is behavioral analysis, isn't it?
That's a really good question, and it's not exactly it's not behavior analysis in the maybe more traditional sense of when you're looking at all of these different indicators and comparing them and trying to use some like machine learning. It's not necessarily doing that. What it's doing instead is looking at the code itself and saying, hey, we know that based off of the code, this is how this function should be executing. And if it's doing something different, then there's an issue there. So it's kind of some behavioral comparisons. It's not completely not behavioral analysis, but you're right. It's a fine distinction.
Okay, I understand it's not the traditional way. Is it only for execution of applications, or is it also, do you compare configurations as well against golden configs or frameworks, etc.?
This specific solution is really just looking at applications as you're executing. Yeah. Okay. And finding your vulnerabilities. Good question, Sal.
Thank you.
Yep. Yeah, that's, I think, another important thing. And I think why it kind of talks about behavioral analysis versus some of the things we're doing with deterministic detection is, again, making sure that you don't have those false positives. So you're not really blocking access to users that are supposed to be, getting there. Because when it comes to like web applications, that's the thing you want, is everybody should be able to access it, get to it, and make it easy. And I think another important piece here is that this is also all post encryption. I think we all know that more and more traffic is being encrypted, and decrypting every communication can't be the only answer for security, right? It's part of it sometimes, but it can't be the only thing. And so by having something that sits at the application itself, it's extremely kind of non-intrusive. If you think about if you're out shopping at a store and the store is so concerned with shoplifting, they ask you to strip down before going in. Are you going to shop there anymore? You need, I think, kind of confidentiality and integrity and availability as well when you're trying to access these as a user. And so that's one of those really important things. And then last but not least, I'll just kind of end here and talk a little bit about the Xero Trust data center, because we know every customer and every organization really has their own configuration of data center locations, some on-prem, some in the cloud, some, using a hybrid approach. But you have users and devices that are trying to access applications and data. And so how all these things come together, the kind of approach we're taking here is, at least, at first glance, it's fairly simple. It's about connecting and protecting all the pathways to that data. So starting at things like the DC interconnect, trying to make sure that the access looks the same as you go from one place to the other, and then everybody gets, right? And if you think about, say, physical security, like on a campus, if you go from a campus, say in DC to one in Sunnyvale, you want to make sure that you don't have to call ahead and that you can get to the same places you're supposed to get from one, kind of site to the other. If you think about the DC WAN gateway, for instance, it's kind of like you have a main guard as you're going into the campus. They're checking your ID or your badge. They're making sure that visitors all have been signed in. And then once you get to where you're going and kind of within the data center, within your cloud environment, you still have to use your badge to, like, you get in the elevator, you have to badge to get to a specific floor. And if you're not allowed on that floor, it's not going to let you go. Or once you get to a specific room, you still have to, use your badge to get in. And so those are all like, segmentation and a lot of, there's some additional visibility you want to gain there. But adding in this last piece is kind of the last mile or the last kind of protection mechanism now to this whole story. It's, you know, once you're in that room that you're supposed to be in, you know, you can think of cloud workload protection as the sprinkler system. You know, you don't notice it if you're, you know, just sitting there, you're not doing anything bad. But if somebody malicious tries to start a fire, it's going to go off. It's going to put out the fire, which is important, but it's also going to set off a bunch of other security alarms and make sure that as that person, right, the pyro is running around your building, that they're not able to go into a different room and start a new fire or go to a different building and do the same thing. It's about, you know, stopping only those who are doing bad things kind of from moving around the entire network. And then I want to turn it over now to Laurent.
So, Krystle, when you
Yes.
start talking about collecting this data and comparing it to known signatures, what actually are you collecting? Is it eBPF? Is it something else? Are you tied into the kernels of the operating systems in some fashion? Because if you're in a container platform, that will be really interesting. What is it actually? What is the data you're getting? Are you, and furthermore, if you're tied into the container, are you tied in at the container level or at the container platform level?
Yeah, one of the things is it's not necessarily, it's tied in, and there's these agents that run at the container level as kind of a sidecar, and then there's individual language-based agents that are looking at how everything is executing. So it's not necessarily signature-based, and this works across both virtual machines, containerized services, as well as kind of serverless functions. So I'll let Laurent jump into the demo and sort of to show some of this off. Let me stop my share here.
Here's the demo. So I created a very simple UI setup with a different UI. You have got a client, which is below. We'll send some web traffic across VS to some web apps. And those web apps have the agent running along with it. So it's already installed, already ready. On the left side, I've got some VS UI and a CLI just to launch some commands. On the right, I will have the console itself, where we'll see everything happening. So let's start with the first part, which is vulnerability detection. So IST, called Interactive Application Security Testing. I got it. I always forget what it means. So let's go right away and expand that window, and then we'll start with discovering what's actually running. So we can see we have an agent, so the cyber agent here, which is runs, and an application. If we go into more details, we can see that we have actually two applications. And then we can see that all happening. They have been here for some hours. You can see them. I can also select past to have what were running before. Those are the ones running now on my servers. On expanding it, I can see that I got 3 agents because I got 3 servers, and actually 3 times the same Vera demo application on one with SQL injection application. They are named by the name of the attacks they kind of support. But that's uneasy. And we can go inside each application and see what are the processes, what is running actually. So it's all discovered over time. What is shared because it's a Docker environment, the port, how it's on which it's listening, and then some web traffic that were already started after the start of the container itself. We can go into deeper information on the application, and then we can see here a bit more details, like it's a Apache Tomcat application with a MySQL application running on top of it. It's running on some specific node, on some group name. There is a group name here because we selectively install the agent based on that group, that vulnerability detection. So it's not in production. It should be in pre-production or specifically in IST mode to let the agent actually scan the container on the applications. And I've got multiple of those environments. I've got those 3 servers on multiple applications. And then I got some critical on high vulnerabilities detection on that one that already started. So I've got production server also. That's the one I will send attack on. And I got 2 of them actually running the same demo, so I can selectively send my attack on those servers 1 and 2, or 2 or 3 here. On the first server is running the IST again with this second server. So here we can see critical on the high vulnerability counts. Since the container started and this app started, the agent was attached to it dynamically, and then it started looking at what's inside and what are the vulnerabilities. So we can go to the vulnerability view and look into these things. So we can see a lot of CVs are visible here. So we have the number of critical CVs, and some are medium and so on. And we can see that this component was one of the running component in this server, and then it's one of those critical things that should be fixed, of course, before being put in production. And we have some high of those ones. But we can go into more details. In the summary view, we see for the last Thursday, the number of exploitable vulnerabilities and the number of third-party vulnerabilities. So exploitable means it's actually able to put some attacks on it and getting some exploitable results, like a SQL injection, for example. And here we have in this page the summary of exploitable and third-party components based on those services running actually in this setup. So all running on the IST nodes, of course. We should not be scanning production nodes. That's what I mean. So we have those three exploitable vulnerabilities, and we can see here the main URL where we get them. On here we can start having more details. So we can see we can exploit using an SQL injection. Here is the request that was made by the agent itself. So the agent is doing actually those requests to this IST running application. And we have the proof of exploit with a lot of details here. And I will pause for a moment because it's really about what has been injected into those requests. And we have an example code, the curl command used to do those information. So we can even copy that and try that on our own later on. I won't do that for the moment, but that's the idea. And we have got the stack trace coming out of the server. If I'm launching the Docker log on this container, I will have exactly this on the console or in the log files. And then some recommendation on what to do on if you are in an environment with Jira installed. If you have for example, in a CI/CD pipeline, you may file a Jira case just to say, hey, this needs to be fixed. And here's the line where it was running. So same thing for the other application. We can see the request that was made. Same thing, the stack trace and remediation for this other attack. And for another application, again, we have various requests possible. And we have all the third party. Third party are usually CVs. And you have all the third party running in those apps. And then we can see in more details for each one. So that's the things I've already shown you. We can come back on some of them. But basically, you will get the same information on all the exploitable vulnerabilities for this one. What is interesting here is that it ties to this application. And we know where it was running. And then you also have some information on the container vulnerabilities. So it means the environment when it runs. So it's not the latest Ubuntu release, but it has been at least updated. So there is still some other things that can be fixed anyway. And we have a daily report, but we can go back to that later. And now let's
Can I jump in with a question here, Laurent, please?
Yeah.
I think I'm missing one thing here, and maybe you covered it a couple minutes ago, but is this checking the traffic that's in the process and seeing if there's active exploits running, or are you running exploits yourself to do the testing, or does this system do both?
It is this part. That's why it's installed on IST nodes. So we install specifically with this configuration to say the agent will actually scan the application. So it is doing the scanning. So when the application runs, it's attached to the agent. The agent will get that configuration and say, oh, I need to scan this container with everything I can find out about what could be vulnerable. Third application on the exploit level it could find. So it is actually running. It is doing what a external scanner will do, but it's doing that from where it is loading. Exactly. But it's not at this time looking for attacks. That's the next part. And the next part is runtime protection in this case.
Okay, so it's active and passive then.
It is
Basically, is what you're
active.
saying.
It is active scanning, and then when we run the agent in protection mode, so on the production servers, basically, it won't scan. And it should not, because it will be catched by the protection mechanism.
Laurent,
Okay,
can you
so,
scroll? Can you move us back so I can see the what it caught?
What it caught here?
Right there.
Yeah, that's for the container parts that we are seeing it. Did you need some specific CVEs or anything here?
I don't.
Okay, thank you very much. I know what it's doing. Thank you.
Okay.
I was just trying to figure out what exactly it was doing, but I get this.
That's for the container part. And the container is not scanning the container itself, but it's looking for any evidence that some CVEs might match also on this space.
Looking at what it appears to be doing, it's looking for components and third-party libraries that exist in the CVSS database.
For the third parties, yes.
So how does it? Right. So if I wrote some custom code that's not using that's not using a library. How does it scan that? What does that look like?
It does scan by sending it requests. That's where it shows exploitable vulnerabilities, because that's where it's able to launch some requests.
So would we have to develop
like this proof of exploit, for example? That's the kind of thing it will try to run.
So does it crawl, like it's a web application in this case? So it would have to crawl through all the URLs and start to determine what the inputs are?
I did not check if it's scanning all the URLs, but basically I would say yes. But it takes between 5 to 30 minutes basically to get everything out of this app. So it might be quicker, but yeah, it's trying to get access and to launch some specific request.
Okay, I think I understand.
So your first scan is basically looking for known libraries with vulnerabilities and other things, known objects. But if I statically link an object, you'll never see it.
That's possible because it won't be a visible object. Here, this part of the demo was using Java. And the Java is compiled but visible content. If it's totally binary, maybe it won't be able to find for third-party elements here, right? So it will be linked to your code.
So you have the first part of this is saying,
but it will be possible for it to try to do some specific commands and find some vulnerabilities. It might not see them, who knows, but it might see also some of them. And then now, if we go to the application protection itself now, it will actually do see the request coming from the network, coming from the agent. From the user itself, let's say. So here we have we can see at the bottom we have a client sending some curl request in a loop every 10 seconds. We can see them on the VS6. So we have some permitted traffic for the moment, crossing it. So just proof of we got some traffic coming in, and we don't have any yet attack in the latest 15 minutes. So we just change here on. We just prepare a few scripts here and then launch it. You see, it says attack failed because it's that the scripting itself, but you can see at the top, it did trigger. Okay, we have the top of the window on my side, but you can see the warning here. And by expanding, we can see that there was a stored cross-site scripting that was launched and actually blocked. And we can see what happened here. So we have the information on the incident ID, and we have all the message, what kind of system has been attacked. We have the application, we have the running server, we have the node IP, everything we know about this, and we have the content of the attack itself. We even have the line number where it was handled by the server itself, where it was blocked. So that's useful for a developer that knows where to look at for this precise attack. We have the stack trace again, that might be useful sometime. And we have the HTTP request that was done. We have here the source IP and source port for this guy, for the attacker machine below. And we also have everything that was sent to this server, including, if any, parameters and URLs and so on. So we can also see that it says on the CLI, it has detected the attack. That was a web output from this. I didn't use a browser, I just used CLI here. And then if this one is trying to get some more access to this server or some others, we can now see the integration with the VS3X because now traffic is blocked for this guy. A dynamic IP address has been set up dynamically by the console, telling to the firewall, now you need to block this guy for the next 2 hours. For every firewall using it, it might be useful if you are blocking. If you have a bunch of servers with a bunch of VS3X in front, or on other sites, it could be on one on Amazon, one on your private, and one on Azure, wherever you want them to run, with a VS3X just before your other resources, so that that bad guy will be blocked everywhere at the same time. So information sharing between the firewalls. And then this guy is still blocked by trying to access for the next time. So that's where this goes. We are at the end of almost at the end of this demo. Also, you can have some. I didn't show it. I forgot to show it, but I got a Slack trace on Slack. I got the attack ID on Slack itself. That can be useful also for other part of the demo, and I'm sure Kelvin could use that in his own automation demo if needed be. Do you have any question?
So I guess a quick question that the communication to, I think, the firewall you mentioned there, let's say the SRX platform to add the deny platform, is that something that comes out of the CWP platform, or is that something that goes through, say, security director that we just got the demo for?
That's a feed created by the CWP platform, the console itself, and the firewall is getting there to get it. So it's not using SD at that point.
So the dynamic objects get pulled from the SRX. The SRX pulls the data from the CWP platform, or is it the other way? Okay.
No. This one consumes from the platform.
Okay.
Yeah, that's in this direction.
So in the container world, you have a scanner for known objects, you have a network tool that blocks ports, and you have a part of the agent that basically does local attacks.
Yeah, this is the same agent actually, but it's configured to do scanning because it's running on a IST mode.
Okay.
When it runs in production mode, it's set to be running protection at the time and not scanning, because we don't want the scanning to trigger some protection.
Why wouldn't you want both?
You generally
because you're not supposed to scan in production.
Yeah, you generally don't want to do those kind of scannings. You don't generally want to do a lot of that scanning in production. It adds in a lot of latency and overhead. You may have scanning mechanisms a lot of times that you'll do, like way we have IDP signatures and things like that. So it's a little bit of a different way where you're not introducing as much latency at the application layer.
I may want to do this at startup of the container and not do it after startup, so I don't have experience of latency.
Generally, yeah, you're wanting your apps to start up very quickly, and as you have things that are elastically scaling, you don't want to introduce that additional latency to scan. The idea is to scan before it ever goes to production, so you don't have those vulnerabilities.
I want it to scan as it goes to production. I want to scan it as it's deployed into production, so I know that there was no hiccup anywhere in that path. Remember, when you use a Kubernetes cluster, it's picking up from an artifact or artifactory or some sort of artifact server repo, and it could get the wrong code. I want to know that. So
and
anytime
actually
in
that's-
that path, I could get something wrong. So having,
Yeah.
but Kubernetes has calls to do this, webhooks to do exactly this.
Yeah, actually, that's a good point, Ed. And we just don't scan at runtime as it's starting up, but there is an option to actually see both post and or so current running containers and some past running containers. So maybe we can show you that part of the demo a little bit later.